Hello everyone and welcome back to PingLearn. Today, I have the pleasure of hosting a very special guest who is a true expert in APIs. Joining us is Eleanor.
Hello. Great to be here.
We'll be diving into some fascinating insights on how to generate ideas for building APIs, how to build them effectively, and how to sell APIs successfully.
That's right.
So if you're curious about building and selling APIs, this episode is definitely for you. We've got a really fantastic set of sources here. They cover, well, pretty much everything from dreaming up an API to actually making money from it securely.
The whole life cycle.
Exactly. And our job today really is to take all that information, all that research, and kind of boil it down.
Distill it into something actionable.
Yes. Actionable knowledge, a sort of blueprint for you, the listener, whether you're thinking about this using, say, no-code tools or maybe more traditional coding.
And that blueprint is super important because the potential upside here, the revenue, it's real.
The sources definitely back that up.
Oh, yeah. They confirm that selling a well-made API can bring in thousands easily. And look, potentially even millions of dollars a year.
Millions, wow.
But, and this is a big but, we need a reality check right at the start. That kind of success isn't just luck.
Right. It's conditional.
Highly conditional. It really depends on nailing 4 key things all at once. First, you need a genuinely strong idea, something the market actually needs.
Okay, idea first.
Makes sense.
Second, a wide enough market that's, hungry for that specific solution.
Yeah.
Third is the professional build, the how-to we're going to get into.
The technical part.
The robust implementation, yeah. And finally, and this is crucial, a successful business and marketing plan to actually connect with developers who'll pay for it.
So 4 pillars: idea, market, build, and business marketing. That's a great framework. But thinking about those 4, did the sources suggest where people usually stumble? Where's the common failure point for someone new to this?
That's a great question. Is it the tech? Do they just get bogged down in the code? Or is it more like they build something cool, but nobody actually needs it?
Well, interestingly, the sources were pretty clear on this. Overwhelmingly, it's the marketing and validation side.
Really? Not the tech?
Not usually the core tech itself.
Right.
New builders, they often fall in love with their clever code, their complex setup.
Yeah, I could see that.
But they skip the hard work of really checking if anyone cares. They don't do rigorous market analysis. So they launch these, technically brilliant APIs.
That solve a problem nobody has, or at least nobody is willing to pay to solve.
Exactly. The successful folks, they get it the other way around. They understand the market demand dictates what needs to be built, not the other way around. The need drives the tech.
That makes a lot of sense. Okay, so let's establish a baseline then.
Right.
For anyone listening who's maybe new to the term API or just needs a quick refresher, what exactly is an API? Let's nail that down.
Right. API, Application Programming Interface. Fundamentally, it's a set of rules. Think of it like a contract or maybe a very strict protocol.
A contract between.
Between different software applications. It acts as a secure bridge or maybe an intermediary, allowing them to talk to each other to exchange data or trigger functions.
Okay, a communication bridge.
Precisely. And they do this in a really organized, efficient way. But here's the key part. The API hides all the internal complexity.
Hides it? How so?
Well, the application using the API doesn't need to know how the other application works internally, how messy its code might be. It just needs to follow the rules of the API, the contract for that bridge. You send the right request, you get the expected data back. Simple as that from the outside.
Okay, so it's like ordering food through a waiter. You tell the waiter what you want based on the menu, that's the API contract, but you don't need to know how the kitchen actually cooks it.
That's a perfect analogy, yeah. The menu and the waiter are the API. The kitchen is the hidden internal system.
And that's why they're everywhere now, right? They're kind of the backbone of the digital world. The sources gave some great examples.
They did. Think about your phone, that weather app you use. When it shows you the current temperature, it's not calculating that itself.
Right, it's getting it from somewhere.
It's making an API call. It's sending a request, following the rules of some weather services API, saying, hey, what's the temperature for this location?
And the weather service sends the data back via the API. The app just displays it.
Exactly. The app has no idea how the weather service collected that data, satellites, ground stations, whatever. It just knows the API contract to ask for it and get it back reliably.
Or another one they mentioned, logging into websites.
Oh, yeah. The login with Google or login with Facebook buttons. Super common.
That whole process, verifying who you are, maybe getting your name and email to pre-fill a form, that's all happening through APIs.
Entirely. It's a standardized, secure API process. Google or Facebook confirms it's you and securely passes back just the necessary information to the website you're logging into.
It seems so seamless.
Yeah.
And thinking about why this is so important, the sources really hammered home the benefits, saving time,
Yeah.
obviously.
Huge time savings for developers. Imagine if every app had to build its own payment processing system from scratch, or its own mapping service.
It would be impossible. Or incredibly slow and expensive.
Right. APIs let developers leverage existing specialized services. It speeds up development massively. Time to market gets way shorter.
And it allows different systems to integrate, to work together.
Seamlessly, ideally. Plus, it enhances the user experience, right? Access to richer data like maps or real-time information.
Yeah. The last big one they mentioned was scalability. How does that work?
Well, as a business grows, its software needs to handle more load, maybe connect to more partners. APIs provide a standardized way for systems to interact, which makes scaling much easier than having point-to-point custom integrations everywhere. It's the language systems used to cooperate effectively as they grow.
Okay, foundational understanding locked in. Let's get into the building process. So the sources laid out two main paths for building. Let's start with the first one, which is all about accessibility. The no-code or low-code approach.
Right. Tools like NAN, Make It, Zapier, they've really changed the game.
Lowered the barrier to entry significantly.
Hugely. And the sources specifically highlighted something interesting, combining these visual tools with AI.
Like using Claude AI, which they mentioned.
Exactly. Even if you're a beginner, you can lean on AI to help generate some of the more complex logic pieces you might need within that visual environment.
So it's making development more democratic, in a way.
Definitely. Someone without a formal computer science degree can start building pretty sophisticated tools.
Okay, so if you go this route, say with NAN, what's the very first piece? The starting point.
The absolute foundation, the entry point for your API in a tool like NAN is the webhook trigger node.
Webhook trigger. Okay, what does that actually do?
So a webhook isn't just a visual block you drag. It's more fundamental. It's an automated mechanism. It listens for incoming HTTP requests from outside systems.
Listens.
Passively listens. When it receives a request that matches its configuration, boom, it automatically starts your NAN workflow.
Ah, so it's the trigger. It kicks everything off.
Precisely. And this is way better than the old way, which was polling.
Polling.
Yeah, where your system would have to constantly ask an external service anything new, over and over again. Super inefficient, uses lots of resources.
Right. The webhook avoids that. It just waits to be notified.
Exactly. It's instant notification. The sources used a great analogy for this.
The smart doorbell.
The smart doorbell, perfect, isn't it? Instead of you constantly peering out the window waiting for the delivery guy.
Which is like polling.
Right. The smart doorbell, the webhook, sends you an instant notification the moment someone rings it. That event triggers whatever you need to do next.
Okay, love that. So setting up this doorbell, you need an address, right?
You do, and that's the webhook URL. It's the specific digital address that other services will send their requests to.
And the sources made a point about two different types of URLs here.
Yes, very important distinction. Often confuses beginners. First, there's the test URL.
Or testing.
Purely for development and safety. You use this URL to send fake requests while you're building and debugging your workflow.
Like testing the doorbell wiring before the house is finished.
Exactly. It lets you trigger the workflow, see if it works, check the data flow, without touching any live data or running real production actions, just for verification.
Okay. And then once you're happy.
Then you switch to the production URL. This is the real deal. The live, public-facing address that your actual users or other services will hit to use your finished API.
Got it. Test first, then production.
Yeah.
And within that URL, there's a part you can edit. The path.
Yes, the path. It's the bit at the end of the URL after the main domain name. Think of the main URL as the street address for an apartment building.
And the path is the specific apartment number, like Unit 101.
Perfect analogy again. It's essential for organization. If you build multiple APIs using the same N8N instance, say one for text detection, one for currency rates, one for image analysis.
They might share the same base URL but need different paths.
Exactly. So our text detection example might use detect. Another might use currency. The path routes the incoming request to the correct workflow, the correct doorbell.
Okay, so the webhook is set up listening at its address. But what kind of ring is it listening for?
Yeah.
That brings us to HTTP request methods, right?
Absolutely. The method tells the server, your webhook node in this case, what kind of action the client wants to perform. There are 4 main ones you need to know.
The sources use a library analogy, which was helpful.
Yeah, if the server is the librarian, the method is what you're asking them to do. The most common one is GET.
GT means retrieve, like asking the librarian for a book.
Exactly. You're requesting information, fetching the weather, getting a user profile. You're just reading data, not changing anything.
Okay, then POST.
POST is for sending or adding new data. Think
Right.
submitting a registration form, uploading a photo, creating a new record. You're adding something to the system.
Right, submitting something new. Then PUDT. The sources mentioned this is sometimes called UPD2.
Yes, PUT, or sometimes PATCH, slight differences but similar idea, is for modifying existing information, like telling the librarian you've changed your phone number on your library card.
So not creating new, but changing something that's already there.
Correct. Updating an existing customer record, changing an order status, and finally, delete.
Pretty self-explanatory.
Yep. Removing data. Deleting an item from your shopping cart, removing a user account. Understanding these 4 get, post, put, delete is fundamental. They define the intent of the call.
Okay, request methods covered. Now, what about the reply? How does the webhook respond back to the client who rang the doorbell? The sources mentioned 2 ways.
2 main settings for response control, yes. The first, simpler way is the automatic response.
Automatic meaning immediate.
Immediate and standard. If you choose this, the moment the webhook receives the request, it instantly sends back a generic success message, usually like HTTP 200 OK, meaning, yep, got it.
Before it actually does the work.
Yes, critically, before your workflow has processed the request, done the analysis, or fetched any data, it's like an automated email reply. Thanks, we received your query. Fast, but doesn't tell you anything about the result.
Okay, so when would you not want that? When do you need the other option?
You need the other option when your API's job is to process something and return a specific calculated result. Like our tech detection API, the whole point is to return the list of detected technologies.
So you need the workflow to finish first.
Exactly. And for that, you select the setting using respond to webhook node. This tells NAN, hold on, don't reply immediately. Wait until the request goes through all the logic nodes, fetching, calculating, error checking, and then send back a customized response using a dedicated respond to webhook node later in the flow.
Ah, so that final node actually crafts the real answer.
Yes, it sends back the actual process data, like the list of technologies, and a specific response code, like 200 for success, or maybe an error code if something went wrong. This is the professional way to build an API that returns computed results. It ensures the response reflects the outcome of the work, not just the receipt of the request.
Okay, so the webhook node is our listener, our smart doorbell. It receives the request, maybe containing a URL to analyze. What's the next step? What actually does something with that URL?
Often the very next step is the HTTP request node. This node is the active part. It takes action based on the trigger.
So if the webhook receives the alert, the HTTP request node makes a call.
Precisely. If the webhook got the target URL from service A, the client calling your API, the HTTP request node then takes that URL and actively goes out to communicate with service B, the target website.
In our tech detection example, it uses the URL it received to go and fetch the website's content.
Exactly. It makes an outbound HTTP request to fetch the HTML source code and the HTTP headers of the target website. It's the node that does the external legwork.
Now, a crucial point the source has emphasized. You can't just type google.com into that HTTP request node. It needs to be dynamic.
Absolutely. Hard coding is brittle. You need it to use the URL that came in with the request. This is where expressions come in.
Right, that slightly scary-looking bit of code.
Yeah.
JSON.query.url, JSON.body.url, JSON.body.url. Let's really unpack this because it seems vital for making a usable API.
It is vital. It looks technical, but the concept is straightforward. Those double curly braces tell NADEN, don't treat this as plain text. Evaluate it as code, as an expression.
Which evaluate it, and JSON refers to.
JSON refers to the incoming data that the webhook received. The data arrives in JSON format.
Got it. So JSON.query.url is looking for a key named URL inside the query part of the incoming data.
Exactly. The query part is data sent in the URL itself, after the question mark, like .detect.url, example.com. This part looks for URL there.
Okay, and the second part, JSON.body.url.
That looks for the same key, URL, but this time inside the body of the incoming request. This is common for PS requests, where data is sent in the main payload, often as JSON.
And in the middle. That's the really clever bit.
That's the logical OR operator. It's the flexibility magic. It tells the node. Try to find the URL in the query parameters first. If it's not there, means OR, then try to find it in the request body.
So it gracefully handles the URL being sent in either of the two common ways.
Precisely. It makes your API much more forgiving and easier for developers to use. They don't have to guess exactly how you expect the input. You're basically saying, send me the URL, however you prefer, query your body, I'll find it. That's professional design.
That's really smart. Okay, so we've used the expression, the HTTP request node fetches the website's HTML and headers. Now what? How do we analyze that raw data?
This is often where the standard pre-built nodes might not be enough. If you need complex calculations, custom data manipulation, or specialized parsing that doesn't fit a standard node, that's when you reach for the code node.
The code node. So even in a low-code environment, sometimes you need actual code.
Exactly. It's the escape hatch for custom logic. It lets you write and execute raw JavaScript right within your visual workflow.
Like a specialist on an assembly line.
Perfect analogy. The regular nodes handle standard tasks. The code node is for the unique, custom job that requires specific instructions, your JavaScript code. Maybe you need to calculate a proprietary score, merge data based on complex rules, format the output in a very specific way.
Things that are unique to your API's value proposition.
Precisely. It's often where the core intellectual property, the secret sauce of your API, lives.
And the sources gave a fantastic example of using AI, specifically Claude AI, to actually write the JavaScript for this code node. The goal was that text detection logic.
Yeah, they didn't just write it from scratch, they prompted the AI.
And the key was how detailed that prompt was.
Absolutely critical. It wasn't just write code to detect web tech. No. It was incredibly specific.
Like what? What did it need to include?
Okay, it specified the inputs. The script must accept HTTP headers and HTML content. It needed to look for specific patterns using regular expressions to identify technologies like Next.js, Vue.js, common content management systems, e-commerce platforms like Shopify, analytics tools.
So a list of targets.
Yes, but much more than that. It demanded rules for how to detect them, not just find this string. It needed definitions for required HTML patterns, specific headers to look for, and crucially, exclusion logic.
Exclusion logic.
Yeah.
To avoid false positives.
Exactly. Things like exclude patterns or exclude headers. If a site have a pattern that looks like technology X, but it also has an exclusion pattern known to be associated with something else, the AI needed to factor that in, maybe lower a confidence score.
Confidence score, that was another requirement.
Yes. The output JSON shouldn't just list technologies. It needed to include categories like framework, CMS, a confidence score, how sure are we, and even a priority setting, so the most important findings appear first.
Wow, that's detailed.
And it went further. It asked the AI to also extract general metadata, the page title, meta description, declared language. And for platforms like WordPress or Shopify, it even asked for specific theme and plugin detection.
That level of detail really turns it from a basic check into a valuable intelligence tool.
That's the difference between a free toy and a sellable professional API, that detailed, nuanced output.
Okay, but I have to push back here, based on what the sources also hinted at. This sounds amazing if it works. But what if you're a low-code user, you put in this perfect prompt, and the AI spits out JavaScript that's buggy? It just doesn't work. Haven't you just hit a wall? Doesn't this low-code path suddenly require you to be a JavaScript expert to fix the AI's errors?
That is, frankly, the biggest risk. You've hit the nail on the head. Relying solely on AI for complex core logic without having any ability to vet or debug it, that's dangerous.
So the sources warned about this.
Explicitly. They stressed that you still need critical thinking. You need enough understanding to look at the AI's code, maybe run it, see the error message if it fails, and have some idea of what might be wrong.
You don't need to be a wizard, maybe.
Yeah.
But you can't be completely clueless.
Right. You need to be able to maybe tweak the prompt, clarify your request to the AI, or even just recognize, okay, this attempt failed, let's start a new conversation with the AI and try a different angle. Low-code lowers the entry barrier, yes, but it doesn't eliminate the need for fundamental problem-solving skills, especially when you're generating custom code for the heart of your API.
Okay, let's assume we navigated that. We used AI, maybe did some minor debugging, and now our code node is working beautifully. It's taking the raw data and outputting that rich structured JSON with all the detected technologies and metadata. What's the final step in this happy path?
The success path concludes by connecting the output of that code node directly to a respond to webhook node.
The second type of response we talked about earlier, the one that waits?
Exactly. This node is responsible for sending the final calculated result back to the client who made the initial request.
And how do you configure this one?
It's pretty straightforward for the success case. Since the code node has already prepared the complete structured data you want to return, you set the respond with option to all incoming items.
Meaning, send everything that just came out of the code node.
Precisely. And crucially, you set the response code to 200. That's the standard HTTP code for OK success. It tells the client, everything worked, here's your data.
Okay, happy path complete. But what if things don't go happily? What if that earlier HTTP request node, the one fetching the website data, fails? The site is down, maybe? Or it actively blocks us? The sources call this the clever question.
Yes, and handling this gracefully is absolutely non-negotiable for a professional API. You cannot just let the workflow crash and burn, leaving the user waiting forever for a response that never comes.
So proper error handling is key. Where does that start?
It starts back in the settings of that initial HTTP request node, the one doing the fetching. There's an option, usually under settings or options, labeled something like on error or error handling.
And what do we set it to?
The critical setting is continue, using error output. Or sometimes it might be phrased like route to error branch.
Continue, even though there was an error.
Yes, this is the magic. Instead of stopping the whole workflow, this setting tells NAN, okay, an error occurred here, don't stop. Instead, activate the second output connector of this node, the error output, and pass the error information down that path.
So the node has two exits. One for success, one for failure.
Exactly. If the fetch works, data goes out the normal exit. If it fails, error information goes out the dedicated error exit. This allows you to build a completely separate branch in your workflow just for handling failures.
And that failure branch also leads to a respond to webhook node.
Yes, but a different one, configured specifically for errors.
How is this error response node configured differently?
Two key ways. First, the response code. You wouldn't send 200 success. You'd send an appropriate error code. The sources suggested 403 forbidden, which often implies the server understood the request but refuses to authorize it, which fits the blocking scenario well. Or maybe a 503 service unavailable if the site was just down.
Okay, an error code, and second, the message.
Yes, the response body. You don't just send the raw error message. You send a clear, structured JSON message explaining the problem to the user. The source provided a really good example.
Let me see, status.error message. The site is either unavailable or has implemented measures to block tracking via headless browsers. Data.null. Okay, that's specific.
Very specific, and that wording is intentional.
Why implemented measures to block tracking via headless browsers? Why not just say failed to fetch?
Because it provides crucial context to the API user, especially if they're paying for the service. Many modern websites have sophisticated anti-bot systems.
Right, they don't want to be scraped or analyzed automatically.
Exactly. They look for signs that the request isn't coming from a real user in a normal browser. They check the user agent string, look for browser fingerprint inconsistencies, maybe run JavaScript challenges that automated tools, headless browsers, often fail.
So this error message tells the user, hey, this isn't just a temporary glitch or a bug in our API. You've likely hit one of those anti-bot walls.
Precisely. It manages expectations. It signals that the target site is actively defending itself, which might require the user to try a different approach or accept that this particular site is off limits for automated analysis via this method. It distinguishes a technical failure from a deliberate block.
Which, as the sources touched on briefly, leads into a whole other world for serious API builders. Right, getting around those blocks.
Yeah, that's a more advanced topic, but important context. For really tough sites, professionals often have to use things like high-quality paid proxy services.
Proxies, to hide where the request is coming from.
Yes, using residential IP addresses, so the request looks like it's coming from a regular home internet connection, not a data center, or even dedicated mobile IPs. Plus, sometimes integrating with CAP-TCHA solving services.
Oh, okay. That sounds complex and potentially expensive.
It is. It's a constant cat-and-mouse game between scrapers and site defenses, and it definitely impacts the operational cost and feasibility of certain data-gathering APIs.
Good context to have. Okay, let's shift gears. We've talked a lot about how to build, but none of this tech matters without a good idea. The sources stressed this was paramount.
Absolutely paramount. You can build the most elegant, robust, error-handled API in the world, But if it doesn't solve a real problem that people are willing to pay for, it's worthless from a business perspective. The idea driven by market need is everything.
So how do you find those golden ideas? What do the sources suggest beyond just solve a problem?
They recommended active market intelligence, spend time on marketplaces like RapidAPI, see what's already popular, what categories get lots of traffic.
Find the demand.
Find the existing demand, but don't just copy. Look for gaps. What's popular but maybe poorly implemented? What has bad reviews? Can you build a better version? Can you add a unique feature? Innovate on existing success.
Okay, analyze the market, look for weaknesses or gaps.
Yeah.
What about specific types of APIs that tend to do well long term?
Yeah, the sources identified several categories that consistently meet core business needs, leading to sustained subscriptions.
Like what?
First, live data services, things that need constant, reliable updates. Think real-time currency exchange rates, stock market data, commodity prices, maybe even flight statuses. Accuracy and low latency are key here.
People pay for reliable, fast data. Got it. What else?
Second, instant translation and media analysis, especially translation that goes beyond basic machine translation, maybe using custom AI models for better context or specific industry jargon. Image and video analysis is also huge. Content moderation, object recognition, that sort of thing.
Okay, data and media processing. Third,
Authentication and single sign-on, SSO. Security is always complex and always changing. Businesses need reliable ways to manage user access securely and comply with regulations. Providing robust, easy-to-integrate authentication APIs is a solid business.
makes sense. And the fourth one you mentioned earlier, which sounded really interesting, linking legacy systems.
Ah, yes, the hidden gem. This is where significant opportunity lies, according to the sources. Think about big established organizations, banks, insurance companies, logistics firms, government departments.
They often run on really old systems, right?
Decades old sometimes, mainframe systems running COBOL. These things are stable, they work, but they don't talk easily to modern web services or cloud platforms.
So an API can bridge that gap.
Exactly. If you can build an API that reliably and securely translates data between, say, an old mainframe format and modern JSON, you're not just providing utility, you might be solving a massive operational headache, enabling digital transformation, or even helping them meet regulatory requirements.
And that kind of solution is probably worth a lot more money.
Potentially orders of magnitude more. You're solving a deep structural business problem for a client with likely deep pockets. That's often where those 6 or even 7-figure annual revenues come from, solving high-value, complex integration problems.
That's a really powerful insight. Beyond those core categories, did the sources mention any more? Unique or distinctive ideas? Things a bit off the beaten path.
They did list a few interesting ones: an API to calculate the carbon footprint of products or supply chains based on various inputs. That taps into the growing demand for sustainability data.
Timely.
Another was managing virtual conferences, handling everything from ticketing and user profiles to streaming integration and virtual networking features. Very niche, but potentially valuable.
And one more.
One that felt very current. APIs focused on detecting fake news or misinformation. Using AI to analyze content, cross-reference sources, check facts, and provide a reliability score. That could be valuable for media companies, platforms, researchers.
Wow, okay. Lots of potential directions beyond the obvious utilities. Right, we've thoroughly explored the no-code, low-code path using N8N, but the sources also detailed phase 2, the traditional development method, building the same API, but with standard coding practices.
Exactly. For developers who need maximum control, maybe need to integrate this API into a larger existing code base or have specific performance requirements, the traditional route using a language and framework is often preferred.
So same goal, the web technology detection API, but different tools. The source is focused on JavaScript using Node.js and the Express.js framework.
That's a very common stack for this kind of work, yes. Express.js is popular because it's quite minimal and flexible, but this approach means you're managing everything yourself.
Server setup, file structures, dependencies.
All of it. More control, but definitely more setup and ongoing maintenance compared to a managed low-code platform.
So just like we needed a detailed prompt for the AI to generate the N8N code node script, the traditional build also started with a prompt for an AI agent.
Yes, but the prompt had to be quite different this time.
How so?
It couldn't just ask for the detection logic. It had to ask the AI to set up the entire Node.js project structure using express.js.
Oh, right. Define the server itself.
Exactly. Set up the basic Express server, maybe configure environment variables for things like the port number, and critically tell it which external libraries or packages to install and use.
Like the package for making the HTTP request to the target website.
Precisely. The prompt needed to specify using a package like Axios or Node Fetch for that task and include the code to import and use it correctly within the Express route handler. It's defining the whole environment, not just one piece of logic.
That brings up a key difference. Handling that flexible input we talked about earlier. In NAN, the expression json.query.url, json.body.url, did the magic. How do you achieve that same flexibility in Express, making sure your single detect endpoint can grab the URL, whether it's sent in the query string, the request body, or maybe even as a URL parameter?
Yeah, Express doesn't do that automatically out of the box. You have to explicitly code that flexibility, usually using middleware.
Middleware, what's that?
Middleware functions are like gatekeepers or processors that run before your main route handler code executes. For handling JSON data sent in the request body, you absolutely need middleware.
Why? Doesn't Express just know it's JSON?
Not inherently for the body. You need to tell Express to use a specific middleware, like express.json. You add app.use express.json near the top of your server setup.
Okay, app.use express.json. What does that do?
It intercepts incoming requests. If it sees the request has a content type header indicating JSON, it reads the raw data stream from the request body, parses it into a JavaScript object, and then attaches that object to rec.body.
So after that middleware runs, rec.body will contain the parsed JSON data.
Exactly. Without that middleware, rec.body would be empty or undefined, even if the client sent JSON.
Okay, so the middleware handles getting the body data. Then, inside our actual detect route handler function, we still need the OR logic.
Yes. Your route handler code would then explicitly check, is there a URL property in rec.query? If yes, use that. If not, is there a URL property in rec.body? If yes, use that. If not, maybe check rec.params for a URL parameter. You code that fallback logic yourself using standard JavaScript if statements or the operator, just like in the N8N expression, but written out explicitly in your function.
Got it. More manual work to achieve the same robustness. Now, you mentioned Axios or Node Fetch for making the outgoing request. Any reason to prefer one over the other in a Node.js environment?
It often comes down to developer preference or existing project standards. Node Fetch is designed to be very similar to the Fetch API built into modern web browsers, so front-end developers often find it familiar. It's generally quite lightweight.
Okay. And Axios?
Axios has been around longer in the Node world and is incredibly popular. It comes with more built-in features that are often handy for back-end development, like automatic transformation of request and response data from JSON, better handling of request timeouts and cancellations, and slightly more convenient error handling sometimes.
So Axios might be a bit more batteries, included for server-side API work.
Often, yes. For a production API, that built-in robustness can be worth the slightly larger package size, but both are perfectly capable.
Okay. Library chosen, middleware setup. What about defining the actual API endpoint, the route itself? How does detect get created in Express compared to dragging a webhook node?
Again, more explicit coding. In N8N, you drop the node, type detect in the path field, done. In Express, you typically have a dedicated file for routes. You'd write something like router.post detect async rec or res.
Router.post specifies the HTTP method, POST, and the path detect.
Right.
And async rec res is the function that runs when a request hits that path.
Exactly. Rec is the request object, containing rec or query, rec.body, etc. And res is the response object you use to send the reply back. Inside that function, you manually call your detection logic, and then you use methods on res, like res.status200.json result to send the successful response, or res.status403.json error message to send an error.
And you also have to handle potential errors within that function yourself.
Critically important. You'd wrap your main logic in a try.catch block. If anything inside the try block throws an error, like the website fetch failing or your detection logic hitting a snag, the catch block catches it, logs it, and sends the appropriate error response using res.status.json. If you don't have proper try.catch, an unhandled error could crash your entire server process.
Okay, much more manual control, but also more responsibility for things like error handling. But the core detection logic itself, the JavaScript that scans the HTML and headers that stays the same.
Fundamentally, yes. The complex analysis part, the brain of the operation, is the same logic, whether it's running inside an NE10 code node or as a separate utility function imported into your Express rare handler. The input, HTML headers, is the same. The output, JSON list of tech, is the same.
The difference is just the surrounding plumbing, how you call it, how you handle its input-output, and how you manage errors around it.
Exactly. It highlights the trade-off. Low-code abstracts away a lot of that plumbing and infrastructure. Traditional code gives you fine-grained control over all of it.
Speaking of infrastructure, what about actually deploying this? The sources mention a contrast here, too.
Big difference. An end-to-end workflow, especially if you're using their cloud service or a similar managed platform, is often deployed by just activating the workflow. The platform handles the servers, scaling, security patches, uptime monitoring.
Pretty simple.
Relatively, yes. With your traditional Express.js API, you are responsible for deployment. That usually means containerizing it with something like Docker.
Putting it in a standardized box.
Right, and then hosting that container on a cloud service, maybe AWS Lambda for serverless, or Azure Functions, or Google Cloud Run, or perhaps a virtual machine like an AWS EC2 instance, or a DigitalOcean droplet.
So you need to manage the hosting environment yourself.
Completely. You're responsible for setting up the infrastructure, configuring autoscaling if needed, managing operating system updates, monitoring performance, and uptime. It gives you ultimate control over the environment and potentially costs, but it's a significant operational burden compared to the managed low-code approach. Control versus complexity again.
All right. We've built our API, either with low-code tools or traditional code. It's robust, handles errors, detects web technologies like a champ. Now for the payoff. Phase 3, selling it. How do we get this in front of paying customers? The sources laid out two main paths.
Yep, two primary routes to market. The first is the traditional path, meaning you build your own platform, your own website. You create the API documentation portal. You integrate a billing system like Stripe. You handle user accounts, password resets, the whole 9 yards.
Total control.
Absolute control over branding, pricing, features, user data. But it's a lot of work up front. And the biggest challenge, marketing. You have to drive all the traffic yourself to your brand new unknown website. That's tough.
Okay, so the alternative.
The alternative, and often the faster path, especially for new builders, is leveraging an existing API marketplace. The big one the source is focused on is RapidAPI.
RapidAPI, like an app store, but for APIs.
Pretty much. It's the largest marketplace. By listing your API there, you get instant access to a huge existing audience of developers who are already searching for API solutions.
So it solves a marketing problem, or at least reduces it significantly.
Greatly reduces the initial friction, yes. Plus, RapidAPI provides tools for documentation, testing, billing, and analytics. And you can see what other APIs are popular, what categories are trending, which helps with market validation.
Okay, that sounds like a strong option for many. Let's walk through the RapidAPI publishing checklist. The sources said the steps are pretty much the same, whether you built with N8N or Express.
They are. The platform doesn't really care how the API was built, just how to interact with it. So first things first, the basics.
Account, project setup.
Right. Create your RapidAPI account. Add a new API project. Give it a clear name, a compelling description, choose the right category, get a decent icon, branding matters, and have your terms of use ready to upload. That's important legally.
Okay, basic profile done. Then the technical connection, the base URL.
Crucial step. This tells RapidAPI where your actual API lives. If you built with Express.js, this is the domain name and base path of your deployed server. Say https://myapi.onrender.com for API.
And if you used N8N,
you copy the production webhook URL that N8N gave you, and this is vital, you must delete the specific endpoint path from the end.
So if the URL is https://n8n.mydomain.com, webhook123 detect, you only put https://n8n.mydomain.com /webhook123 into RapidAPI's base URL field.
Exactly. RapidAPI needs the base address. You'll define the specific detect path later when you configure the endpoint itself. Get the base URL wrong and nothing will work.
Got it. Base URL set. What about proving reliability, the health check?
Yes, highly recommended, shows you're serious. RapidAPI lets you provide a separate, simple URL endpoint that they can ping periodically, maybe every few minutes.
Just to see if the service is alive.
Exactly. In N8N, you'd set up another super simple webhook trigger that just returns a 200 OK response immediately.
Yeah.
You give that specific ping URL to RapidAPI. If their check fails, they'll email you saying your API might be down.
So you can fix it before too many users notice. Smart.
Very smart. Builds trust.
Okay, base URL and health check done. Now we define the actual API endpoint within RapidAPI.
Right. In the Definitions or Endpoints tab, here's where you formally tell RapidAPI about your detect endpoint. You click Add REST Endpoint.
And you specify the details.
You specify the HTTP method, which is PST for our example, and you specify the path, which is detect. This must exactly match the path you configured in N8N or your Express router.
Okay, method and path defined. What about the input, the URL parameter?
Good point. You then need to configure the expected inputs. Usually there's a query parameters or request body tab. Since our flexible design accepts the URL in the query string, you'd go to the query tab.
And add URL there.
Add a parameter named URL. You should also provide an example value, like https.google.com. This is super helpful because it lets users test the API directly from the RapidAPI website using that example.
Makes it easy to try before they buy. Okay, endpoint defined, input defined. Time to test.
Absolutely critical. Save everything, then use the test endpoint button right there in the RapidAPI interface. It will make a live call to your actual API using the base URL, the path, the method, and the example input you provided.
Then what are we hoping to see?
That glorious 200 OK status response, and importantly, the actual JSON data coming back from your API in the response body.
List of detected technologies.
Exactly. Once you get that successful 200 OK and see the correct JSON response, you need to do one more thing here. Copy that entire successful JSON response payload.
Copy it. Why?
And paste it into the example response section for that endpoint definition. This serves as documentation. It shows potential users exactly what a successful response looks like, the structure, the keys, everything. Immensely helpful.
Got it. Test, confirm success, save the response as an example. What else before we get to money?
Two small but important things. In the general settings, make sure you set the API visibility to public so people can find it. And take the time to fill out the docs tab properly. Good documentation explaining what the API does, how to use it, what the parameters mean, maybe some code examples is often the deciding factor for a developer choosing your API. Don't skimp on docs.
Excellent advice. Okay, docs done. API is public. Now, the monetization tab, the exciting part.
This is where the business happens. This tab is where you define how you'll charge for your API.
Pricing plans.
Exactly. You'll typically set up multiple tiers, maybe a free basic plan with very limited requests, like 100 calls per month so people can try it out. Then a pro plan with more requests for a monthly fee, maybe an ultra or enterprise plan with high limits or custom features.
And you set the price and the request limits for each tier.
Yes. You define the quota limits, requests per second, per day, per month, and the price for each subscription tier. RapidAPI handles the billing and metering based on these plans. This structure is your entire revenue model, so think carefully about the value you provide at each price point. Okay, we're almost there. The API is built, documented, listed on RapidAPI, and pricing plans are defined. But there's one absolutely critical final step before you unleash it onto the paying public.
Which is?
Security. You must secure your API endpoint so that only authenticated paying subscribers can actually use it. You can't just leave your NEN production webhook URL or your Express endpoint wide open.
Right, otherwise anyone could use it for free, bypassing the RapidAPI plans. How do we lock it down?
RapidAPI provides a mechanism for this via its gateway. The idea is that all requests from users will first hit the RapidAPI gateway, which will check if the user is subscribed and authorized. If they are, RapidAPI will add a special secret key or token to the request before forwarding it to your actual backend API.
So our backend just needs to check for that secret token.
Exactly. The most common way, detailed in the sources, is using an authorization header.
How do we set that up?
In the RapidAPI dashboard, you go to the Gateway tab, sometimes called Security or Transformations. You'll configure it to add a specific HTTP header to incoming requests. Usually, you'd choose Header Authentication.
Okay, header off, and we define the header.
Yes. You'll define a header name, typically authorization, although RapidAPI often uses its own custom headers like X RapidAPI proxy secret. Let's stick with the concept of adding a secret. You'll generate a strong, random secret token, use a password generator, make it long and complex.
Okay, generate a secret token, where does it go?
You configure the RapidAPI gateway to add a header, say XAPI key, and set its value to that secret token you just generated. So when a valid user makes a call via RapidAPI, the gateway adds XAPI key, your super secret token, to the request before it hits your server.
Got it. Gateway adds the secret header. But now, our backend needs to check for it, right? This is the crucial synchronization you mentioned.
Absolutely critical synchronization step. That same secret token value, your super secret token, must now be configured back in your N98N workflow or your express.js code.
How?
In NAN, you'd likely modify the webhook trigger node's settings. There should be an option for authentication or security. You'd select header auth and tell it to expect a header named XAPI key and paste in the exact same secret token value.
And an express.
In your Express route handler, or potentially in a dedicated authentication middleware, you'd write code to explicitly check the incoming request headers. If rec.headers XAP key your super secret token, deny access.
So if the header is missing or the token doesn't match exactly, the backend rejects the request.
Correct. It should immediately return a 401 unauthorized or 403 forbidden error. This ensures that only requests that have passed through the RapidAPI gateway and carry the correct secret are processed by your actual API logic. The gateway verifies the subscription, your backend verifies the gateway.
That makes sense. 2 layers of checks. The sources also mentioned using bearer tokens, sometimes with the authorization header. Is that different?
Slightly different standard, often used with O or JWT tokens. The principle is similar. The authorization header would contain bearer your access token. If you use that standard, both RapidAPI, if it supports generating forwarding bearer tokens, and your backend need to be configured to expect and validate that specific bearer token format. The key is consistency between the gateway setup and your backend validation logic. For simple API key security, a custom header like XAPI key is often easier.
Okay, stick with a custom header and secret token for this example. Security configured on both ends. What's the absolute final step?
One last test. Make a request to your API through the RapidAPI test endpoint button again. This time, RapidAPI will automatically include the security header, like XAPI key it's configured to add.
And we're looking for...
Still looking for that 200 OK. If you get a 200 OK response, it confirms that the RapidAPI gateway added the header correctly, your backend received it, validated the secret token successfully, processed the request, and returned the result. Security is active and working.
And now it's ready for prime time.
Now it's a secured, documented, monetized asset, ready for the market. #tag outro.
Wow, okay. What a journey. We've really covered the full spectrum here, haven't we?
Yeah.
From just defining what an API is, that fundamental contract, to exploring 2 totally different ways to build one. You've got the visual, accessible path with tools like NNA, great for getting started quickly, or for less code-heavy tasks.
Right, lowering that barrier.
And then the traditional robust approach with Node.js and Express, giving you that deep control needed for maybe more complex or enterprise-level stuff.
And we saw how AI can play a role in both, generating that core logic, but with that important caveat about needing to verify it.
Definitely. Plus, implementing that professional error handling, planning for failure, and finally, navigating the steps to actually sell it securely on a platform like RapidAPI, it feels like a complete roadmap.
It really is. And if there's one core lesson to take away from all the sources, it's this. While the tech is interesting, success really boils down to the value of your idea.
Back to square one, almost.
In a way, are you solving a real recognized problem, a daily pain point? If you nail that and you implement it professionally robustly with good error handling, flexibility, and proper security, that's the combination that turns a side project into potentially a real, scalable, revenue-generating business in the API economy. The idea drives everything.
That's a perfect summary. And it leads nicely into a final thought, something for you, the listener, to chew on. We talked about error handling, especially that specific message about sites blocking headless browsers and the need for advanced proxies or CAPTTCA solvers to get around sophisticated anti-bot measures.
Right, that technical arms race.
Exactly. So thinking about that ongoing battle, how might this increasing sophistication of website defenses, this constant raising of the walls against automated access, influence the future profitability of APIs that rely on scraping public web data? Will the rising cost and complexity of just accessing the data force API prices up? Or will it push successful API businesses towards only providing data that's explicitly sanctioned or static, fundamentally changing what kinds of data-driven APIs are even viable in the next 5 years? Where's that line between legitimate data aggregation and unsustainable scraping? Something to definitely mull over as you plan your own API venture.